Students, welcome to s.mathguru classes. So we consider one new topic. Lagrange linear equation is an equation of the type capital P small p q q capital Q small q equal to capital R, where p q r are the functions of x, y, z, and p equal to del z del x, q equal to del z del y. If we get this type of equation, Pp+Q equal to R, then how to solve this type of problem? We have some problems, but P means sometimes we get del Z del X and del Z del Y, Q. Working rule to solve Pp+Q equal to R. If we get this type of problem, the working rule is that this is step 1. So this equation we can write in this way: P, and this is del Z del x, q del z del y equal to r. If we get this type of equation, either this or this form, then first we write step 1, write down the auxiliary equations dx by p, this p, dy by q, dz by r. Just we write dx by p, dy by q, dz by r. Step 2, solve the above auxiliary equation. This is called auxiliary equation. Let the two solution be, one solution we get u equal to c1 and another solution we get v equal to c2. If we solving these two, first we consider this pair, next this pair. If we solving this equation, suppose first equation, first pair, from first pair we get this answer u equal to c1, and second pair we get v equal to c2. Then the required solution will be then f of u comma v. This u and v we write in this way: f of u comma v equal to 0 are the required solution, or u equal to phi of v. Either we can write this form or this form is the required solution of Pp+Q equal to R. This is our main working rule. By using this working rule, we can easily solve some problems. Very easy, very interesting, and very important also. Now this, we want to solve this problem. Solve the following partial differential equation: yq minus xp equal to z, where p equal to del z del s, q equal to del z del y. Now solution is start. Here yq minus xp equal to z given. So yp, so our main formula is pp qq equal to r. Then we write this is dx by capital P, dy by capital Q, dz by capital R. This is our auxiliary equation. If we get this equation Pp+Qq equal to R, then dx by P, this capital P, dy by this capital Q, and dz by capital R. So here we get, this is capital P means here x, or we can write in this way minus xp plus yq equal to z. This minus x means capital P, y means q, and this is r. The auxiliary equations are dx by minus x, dy by y, dz by z. Just like this, dx by capital P, dy by capital Q, and dz by capital R. So here capital P means minus x, this is Q, this is R. So we get this. This is number 1 we consider. Now we are taking first two parts. From first to from first two members we get from first two members we get, that means these two we consider, dx by minus x dy by y. We integrate both sides, dx by x and minus dy by y, this minus taking right hand side, and we get this if we integrate this one, and dx by x means log x, dy by y means log y, and we consider this is log c1. This equal to log x plus log y equal to log c1. This implies log x into y log c1. Just in logarithm, if plus given we write into, and this implies xy equal to c1. We get first value u we get. Next we consider second pair. Again from second pair, these two members, again dy by y dz by z, this we integrate this dy by y dz by z, dy by y means log y, dz by z means log z, and we consider log c2, and this is log y minus log z equal to log c2. Log y by z in logarithm minus means division, this is log c2, then y by z equal to c2. We get this one. That means we know if u equal to c1, so if u equal to c1, v equal to c2, then solution is f of u comma v equal to 0, or we can write u equal to phi of v. This will be our solution. If u equal to c1, v equal to c2, then answer will be, solution will be f of u comma v equal to 0, or u equal to phi of v. This is u equal to c1, this one v equal to c2. Therefore, the required solution is f of xy comma y by z equal to 0, and this is our final answer. Just write down this comma this, f of this comma this, these are required solution. Next we consider this problem. Solve y²p minus xyq equal to x into z minus twice y. Now we want to solve this equation given that y²p minus xyq equal to x z minus twice y. We get this. But our main equation is Pp+Q equal to R. Then this is P, capital P, and this minus xy is capital Q, and this whole is R. Then at a time the auxiliary equation dx by capital P, dy by capital Q, and dz by capital R. This is our auxiliary equation. So here therefore the auxiliary equations are dx by y square dy by minus xy dz by x into z minus twice y. We get this. This is our mean auxiliary equation. This is P, capital P, this one capital Q, this whole is R. By using this formula, we get this. Now we consider first pair. Now dx by y square dy by minus xy. This is number 1 we consider from first two pairs. This two we consider, and from this y is cancel. We get dx by y dy by minus x, and multiplying this on this side, x dx minus y dy, and we integrate this x dx minus y dy. This integration x dx means x square by 2, this is y dy means y square by 2, and we consider c1 by 2. This implies x square equal to minus y square plus c1. If we dividing both sides by 2, we get this, and taking y square in left hand side, x square plus y square equal to c1. We get this equation. Again we consider second pair. Now we consider second pair. Again dy by minus xy dz by x into z minus twice y. We consider this. Now this xx cancel, then we get minus dy by y dz by z minus 2y. This one multiplying left hand side, z minus 2y dy and y dz. So this is minus z dy twice y dy y dz. Then 2y dy y dz plus z dy. Taking this one on right hand side, and this is remains same, this is this. Now we write in this way 2y dy, and this can be written as dy into z. Dy into z, we get this one. And integrating both sides, 2, this is y square by 2, this is yz plus c2. So this implies y square equal to yz plus c2. This implies y square minus yz equal to c2. So what we get? We know this formula. If u equal to c1, v equal to c2, then f u comma v, this is our recurrent solution. Or we can write u equal to phi of v, this. So we get this is u equal to c1, this is v, and this one v equal to c2. Therefore, the recurrent solution is f of x square plus y square comma y square minus yz equal to 0, or we can write x square plus y square equal to phi of y square minus yz. We can write in this way also. Either this or this. Better to write this equation. This is our final answer. So there, students, these are very important, very interesting, very easy, very simple. These are for engineering courses and BSc major also. MSc also we have this syllabus. According to this, we can solve this equation. So I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.